All right, so I'm actually going to start with worksheet 3B. I'm going to come back to adding vectors. I don't know if this is a good plan or not, but I'm trying it. All right, we talked yesterday about component form of vectors. And so today we're going to talk more about vectors. They're going to talk about a unit vector. And this is when you have a vector. I don't have a cursor. Hang on. My usual struggles here. All right. So it says I is the vector that would just take you one direction. Which way? 1, 0 would be to the right one. Yes? Okay. And they're going to call J this magical vector that would take you up 1. All right. So they're going to call it a linear combination. So guys, it's this easy. If I write this, it is equivalent to, does that seem okay? All they're doing, it has to do with notation used in different professions and courses and all this kind of stuff. But it's I is every time you move 1 to the right, you put an I, and every time you move up 3, you put a J. In this case, it's down, so it's -3. Easy peasy, right? That could be all over the quiz and you'd be on it. All right, a unit vector means you take either one of these and you reduce it to 1 unit long. So what you have to do is you have to find the length of the original and then divide each piece off. In other words, guys, if I wanted a vector that had the same direction as one that was going to the right 5 and up 5, I could go to the right 1 and up 1, right? But if I wanted this to be the same, okay, then I could find that magnitude or that and divide it into both of those. So for my example over here, you do Pythagorean theorem, 2 squared plus -3 squared would be 4, and 9 would be 13, yes? And then you'd square that, and then you would divide each of these by square root of 13 to make it a unit vector. All right, so let's see what we have. So here's their example. They say -2, 3, okay? -2, 3. So then is that the numbers I just had? Yeah, nice. Okay, opposite signs. They did Pythagorean theorem, and they got square root of 13, and they divided each and magically rationalized the denominator. Okay, so here's our question. This could be written as this, okay? We just covered that notation. And if we wanted to make it into a unit vector, you would find the length first. What's square root of -4 squared plus -1 squared would be what? Anybody? Square root of 17. So we could go -4 over square root of 17, or -4 square root of 17 over 17. And the x would be -1 over square root of 17, or negative square root of 17 over 17. So this is the unit vector, okay, that goes in this blank. As I may have mentioned a minute ago, it's not on the quiz. I didn't put unit vector on the quiz, okay? But let's just do one more easy one. We won't even do this one, but guys, what is the magnitude of this? If we went 4 to the right and down 3, this is the actual vector P right here. How long is it? We know this one. 5, right? 3, 4, 5 triangle. So if P is 5, what they're saying is if we wanted to reduce this down so this was 1 unit long, kind of like putting it on our unit circle, okay, then we'd have to divide everything here by 5, and it would go over how much? 4/5 and down 3/5. So it'd be 4/5, 3/5, and 1, 5/5. All right, we're not going to do 8 because I didn't put it on the quiz. All right. It says here, just be careful. This I that we're talking about is not an imaginary number. And this method we just talked about is actually called a linear combination when you put in the i's and the j's. So remember from yesterday. Okay, we have a vector that goes DE. Do you remember how this works? It goes from -2 to +4. That's 6. It goes from 3 to 5 is 2. So we have this vector, which could also be written like this and could be changed into a unit vector if we cared. All right, so here's their question. 2, 2, and 5, 4. If we wanted to go from M to P, we go from 2 to 5 is +3. From 2 to 4 is +2. So if we wanted to write that as an ij or linear combination vector, we'd write 3i plus 2j. Easy peasy. Okay, let's do these two. Do you remember how it went? From 2 to -5. This concept is on the quiz, okay? That concept of finding the original vector here. From 2 to -5 is -7. Or remember, you could go -5 minus 2. Gotta go, if you're gonna subtract, you gotta do it backwards. And from 8 to -3 is -3 minus 8. Okay, so that's the answer I'd be looking for on the quiz. And I also asked you the magnitude on the quiz, which means you do what? Pythagorean theorem, right? Magnitude means Pythagorean theorem, find the length of the vector. Okay, one more time. In other words, there was a point M over here at 2, 8. There's a point N at -5, -3, and the vector looked like this. An equivalent vector, if I were to attempt to copy this vector, an equivalent vector would look like this. It would go -7 and -11. Does that make sense now, what we're doing? Okay. And the length of that vector, you could do Pythagorean theorem to find. All right. The only thing they want us to do on this question is write it in this silly ij form. Okay, which unfortunately I didn't put on the quiz either. It would have been easy points, but just one more thing you would have had to remember. But let's practice with this one. From 0 to 18 is 18. From 6 to 4 is down 2. Okay. So 18i minus 2j. Could you find the magnitude if you had to? It would be square root of 18 squared plus -2 squared. So the magnitude of that vector would be, I don't know. Square root of 68 or a, yeah, I totally didn't type it right. Square root of 328 or 18.1. Okay, so yeah, I don't want to do the unit vector thing either, so let's be done with that, okay? All right, these are given the length of a vector, this means magnitude or length, and an angle, okay? We're supposed to find the component form. So basically it's what we did yesterday. This is 240 degrees, and there's a vector of 18. How do we change that into x and y components? Do you remember? Yeah, it's this notation that they're using here. Everybody see that? Magnitude times the cosine of the angle, magnitude times the sine of the angle. Yesterday I said r cosine theta and r sine theta. It's the same thing. So, going the wrong way, sorry. This one says exact. Anybody know why it says exact? Anybody know why we could do that one exactly? Do you remember such a thing as a unit circle? Okay, the cosine of 240 is on the unit circle, yes? So could we, or 240 is on the unit circle. Could we find its exact cosine? It's a 60-degree angle down here. So it would be left 1/2 and down square root of 3 over 2. Okay, so if that's the ordered pair, what is the exact value here? 18 times, what's the cosine? Yep, would be -9. And over here, 18 times negative square root of 3 over 2 would be what, guys? -9 square roots of 3, yes? Okay, so you could use the sine and the cosine off the unit circle. Would you feel better if I said, I'll take either answer? You could give me the decimals on the quiz or the exact answer. Okay, so you could type 18 cosine 240, 18 sine 240 and get decimals for those, and I'd take it. All right, so what about this one? Is this one going to use the unit circle? No. It's 5 long and the angle with the x is 95 degrees. So we need to do 5 cosine of 95 and 5 sine of 95. What kind of an answer? I just need positive, negative. Should I get here, guys? In this quadrant, I should get a what? A negative x and a positive y. Okay? I got to make sure I'm in degrees, and I'm not. Okay, changing to degrees. 5 cosine 95 and 5 sine 95 gives me negative 0.44 and 4.98, something like that. Anybody else getting that, or did I type something wrong? Anybody getting that? Okay. Making me nervous. All right. What we did not talk about hardly at all yesterday, I may have mentioned it once, is finding the angle it makes. Okay? If we were here, okay, this one gave us an angle, but when we have quantities or components, we can find the angle it makes using, so if I had 3, 4, you'd say I went over 3 and up 4. If you wanted to find that angle, you could do inverse tangent of 4/3. Everybody with me? What I'm talking about here? Okay? Yes? All right. So here's an example. It says 3, 7 is the vector. So they did 3, 7 really means this. They have 3i plus 7j. And then they did inverse tangent of the y over the x, and they got this. This vector was in quadrant 1, so the angle is correct. The problem is the angle's not always right. 4, -5. What quadrant is that in? 4, -5, right? How would I do inverse tangent? Tangent is always what over what, guys? Opposite over adjacent, or y over x? Using the original point, we could just do y over x. Okay, when I do inverse tangent, -5 divided by 4, I get negative 51.3 degrees. Is that in the right quadrant? Yes. Could I rename that if I wanted to by adding 360? Yes. But I would take either one of those answers because at least it's in the right quadrant. All right. This is going to show you ones that aren't. Let's do this one. -6, 2. What quadrant should that wind up in, guys? Quadrant 2, right? Okay. I want you to find the inverse tangent. This is on the quiz, so please be awake here. -6, 2 would be inverse tangent of what? What am I typing? 2 over negative 6 is negative 18.4 degrees. Yes? Are you in degrees? You good? Oh, I did too. 2 over negative 6? Oh, gotcha. Okay. Do you remember the whole inverse functions, how they had certain ranges of values that they found? Remember on the quiz, we colored the unit circle. You with me for a second here? Inverse sine, you had to look in quadrants 1 and 4. Inverse cosine, you had to look in quadrants 1 and 2. And inverse tangent, you had to look in quadrants 1 and 4. Remember this now? Colored unit circle. Okay. We want an answer in quadrant 2. The calculator is never going to give you an answer in quadrant 2 because of what we just talked about. Inverse tangent is only defined in quadrants 1 and 4. How are we going to say, oh, that should have been in quadrant 2? If they think we're down here 18, we're really over here, how are we going to do that? Just add 180. Just add 180 because we need a quadrant 2 answer. So negative 18.4 plus 180 is 161.6 degrees. Okay? That's off the positive x-axis, and it's in quadrant 2. All right? This one is what quadrant? Negative 3, negative 8. Okay? Inverse tangent, which one divided by which one? Y over x, so negative 8 divided by negative 3 gives me 69.4. Right quadrant? You just told me it was over here. How are we going to move that around to here? Add 180. And I can't add 180. What is that, guys? 249.4? I typed it wrong. Okay. All right, so let's do these two real fast. What quadrant is this one in? It's just another way of writing this, which is in quadrant 2. So when I'm done, my answer needs to be between 90 and 180 if I'm doing this in degrees, okay? So I'm going to go inverse tangent of y over x and get negative 26.6 degrees. Because going left 4 and up 2, okay, it thinks you're down here. And we really want to be over here. So what's the angle with the x-axis? This angle in here is 26.6 in the triangle. But I always want an angle with the x-axis, so I just add 180. And anybody get an answer? Okay. Just before we forget this, could we also find the magnitude? We just do Pythagorean theorem, right? Just making sure we didn't forget that. Okay. This is an easy one because it's quadrant 1. Over 2 up 17. Inverse tangent of 17 divided by 2 is just 83.3 degrees. We're good because we don't need to move into a different quadrant. All right. So this is the assignment on 497. If you picked up the book, this should say 8.1. Just kidding. If you picked up the bookwork yesterday that I put out in the back, okay, it had 8.1 on one side and 8.2 on the other, just so you know, okay? All right, I am going back to 8.1 because we need to do applications till they come out our ears. Okay, on 8.1, we need to add vectors, okay? We need to add vectors. There are two ways to do this. There's a tip-to-tail parallelogram business, uses law of sines and cosines. There is also just using the components. If you are currently in physics and you really got and understood the tip to tail thing and want to do them that way, I'm all for it. I'm only going to spend time teaching the component form because I think it's easier and it will work for all the different things we're going to do. But I can do one example if you need me to tie the two together for you, okay? I want you to just watch this. An airplane is flying with an airspeed of 310 knots with a heading of 050. What does that mean? Off of north in a clockwise direction. Remember this? Okay. So to do my component form, I need this angle, which would be 40 degrees. Did I lose anybody yet? Okay. And this was 310 knots. So my component form is going to go 310 cosine of 40 and 310 sine of 40. All right. Then it says if a 78 knot wind is blowing from a true heading of 125, which is again off of north 125 degrees. I don't know why they phrased it differently, but true bearings are still off of north. Determine the speed and direction. Okay, this is what kills everyone. Is this the wind is blowing to this way or from this way? Okay, when the wind is blowing from this way, it means it's actually pushing the plane this way. Does that make sense, guys? Okay, so this is literally what I did on the quiz when this question is on the quiz. I made this whole thing a dotted line and I pushed it through into that quadrant. That was my hint, okay? Because this is the vector you really want, because that's what's acting against this. All right, and it's 78 knots. Now, if the angle originally, this is where I lose people, are you with me? The original angle off north was 125. So what's this angle in here? Off of north, 125 minus 90 would be 35 degrees, okay? I need the angle, to do components, I need the angle off of east. So I need this angle around to here. This is 35, right? Because of vertical angles. Told you we needed a lot of geometry. So this is 180 minus 35, or 120, 145. Help me, someone. Okay. That was the hardest part of the question right there. Okay. Now we have 78 cosine of 145 and 78 sine of 145. Okay, we need to find the resultant when those both act on the plane. What we're going to do is add them together. We're going to add straight down, straight down. So type 310 cosine 40. Please be doing this because I need you to get this idea cemented in your head. Plus 78 cosine of 145. I got 173 point, I'm going to round to 6. Is that okay? Now do it again on the up and down part of the vector, or the vertical part. 310 sine 40, close your parenthesis, plus 78 sine 145. I got 244.0. Anybody else? Okay. Want to know the actual speed of the plane in knots? What are we going to do? Magnitude, which is Pythagorean theorem, yes? Square root of 173.6 squared plus 244 squared. I got 299.45 or almost 300. Did anybody get that? Okay. Does it make sense, guys, that this plane thinks it's flying 300, but because of the way the wind is pushing against it, that it would slow the plane down a little bit? Okay. The direction Okay, second hardest part of the problem. First of all, just do inverse tangent here. Inverse tangent 244 divided by 173.6, because it's always y over x, yes? I got 54.6. Did someone else get that? Okay, what is that angle off of the... This is off of x. Whenever we do inverse tangent on our calculator, it's off of x, right? We want the bearing. So how would we find that? If the plane actually is here at 54.6, its bearing is 90 minus 54.6 is 35.4. Okay. At bearing 035 degrees. All right. So 99.4, is that what we got? Or 0.5? We got 0.45 or something. And 35.4 degrees. We rock it. Okay. Now, I'm going to go back and attempt to show you the tip to tail. Okay? To do tip to tail, the wind is pushing it this way. So you slide, this is the tip, this is the tail of the other one. You slide them in a parallelogram form. Does everybody see that? That makes a parallelogram right there. Okay. This vector was how long? I forgot. 310. And this vector, oh, you don't even have this, do you? So it would be helpful if I... 310 and 78. Okay. Then this is where the gobbledygook comes in. We want to find how long this green vector is. So we have to use law of cosines, and we need this angle right in here. All right. When we... This is easier? Okay. When we did the red one, the angle here was 40 degrees because the bearing was 50. Okay. So the bearing here was 50, which made this 40. This was 50. All right. The wind was 125. So the wind was around here to 125. When we subtracted 90, this was 35. Okay, so what's that red angle since this is so easy? This one right here. Yeah, it's 75 degrees because this is alternate interior. Do you see right here? The blue and the red. So these two together are 75. So if we did law of cosines, does anyone remember law of cosines? 78 squared plus 310 squared minus 2 times 78 times 310 times the cosine of 75 degrees, okay? Typing very fast. 78 squared plus 310 squared minus 2 times 78 times 310 times the cosine of 75 gives me a great big number that I then have to square root, and it comes out 299.4. Does that sound familiar? Okay. Then what you have to find, okay, is somehow they want you to find this angle. How far off there it is. Okay. So you could do that a lot of different ways, but usually we use some kind of law of sines to find one of the missing angles in the triangle and then find that angle. For example, if I found the angle between the green and the red, I could find this one. All kinds of fun. Can I just move on? Okay. Do you have this swimming question? Okay. You have this question. Okay. I would like us to get through this question and then we'll do some of the homework together. A helicopter is moving 15 degrees north of east. Okay, what does this mean? We haven't even done one with that kind of notation. North of east means, okay, 15 degrees north of east. It's actually a very nice, because it's already off the positive x-axis, right? And it's moving at 52 kilometers per hour. So to find the components of the helicopter before we go any further, what would I type? 52 cosine of 15, 52 sine of 15. Okay. If a 30 kilometer per hour wind is blowing from a bearing of 250, okay, here's where I lose people. Bearing of 250 means off of north. When we're all done, we need it off the positive x-axis, okay, to do components. A bearing of 250 would be here, yes? Not quite 270? Okay, wait a minute. But it's blowing from over there. Mr. Wind is howling this way. He's actually pushing it back this way. Okay, and I didn't draw this accurately, so it's very hard to tell what's going on. But if this is 15 degrees, guys, 270 would be 20 degrees away from there. Is that right? So it's blowing at 20 degrees here. That angle in there is 20 degrees. The wind is actually 30. Okay. Right here, it's 30 kilometers. But just back up a minute. Let's draw it separately because I think it'll help you. Okay. So here's the first one, 15 degrees, 52 kilometers per hour. Okay. Then there's the wind, separate picture. It's 250, which makes this angle in here 20 degrees. Are you with me? Which means if the wind is blowing from that direction, this is the actual wind vector over here. And it's 30 kilometers long. And the angle in here is what? Vertical angles, 20 degrees, right? Okay, so I need the component of that, the wind. How do I find that? 30 cosine 20, 30 sine 20. Okay, add those together. 52 cosine of 15, close parenthesis, plus 30 cosine of 20. (52 sine of 15, close parenthesis, plus 30 sine of 20. Did anyone get those numbers? Yes? Okay. How do we find how fast the plane is actually, or the helicopter is actually moving? Pythagorean theorem. Okay. So it's going to depend how many decimals you use when you do this, but somewhere around 81.9. Did someone else use less decimals and get something different? Or is it about 81.9 either way? 78.4 squared plus 23.7 squared comes out to be about 81.9 kilometers per hour. How can a helicopter that thought it was flying 52 actually be flying 81.9? Because that wind is almost directly behind it, right? If it was exactly directly behind it, it would have been going 82, because the 30 and the 52 would both be acting exactly together. It's not quite exactly together. Okay? because there's a little bit of an angle, it's not pushing exactly behind it. We need to figure out the direction it's actually flying. Okay? So I want us to do inverse tangent of this. I know I've made this slide a total disaster. 23.7 over 78.4. Inverse tangent of 23.7 over 78.4 is 16.81. Okay? That's the angle off the positive x-axis. Everything else in this question when we started was a what? A bearing? Can we find the bearing? If this is off of... Yes, it was. Oh, it was north of east. Okay, we could, yes, we could leave it. I could live with that. 16.2 degrees north of east, right? Because that's... Oh, it is 0.8. 16.8. Thanks. 16.8, okay? It thought it was flying 15, but the wind pushed it off a degree 1.8, right? Okay. All right. Now, this is your homework on this stuff, but we have two options. Okay? Day 2 worksheet. Where's my slide here? Here. Okay? Guys, day 2, okay? I need you to focus here, is to add these vector problems. Now we have two options in the 10 minutes that are left, or 8 minutes that are left. I vote we try a couple of these book problems. No, you want to do the ones off the worksheet? Yeah. Okay. All right. Because you're not even going to bother to do the ones off the worksheet, is that what you're telling me? Okay, let's try number 5. Do you want to do 2 separate drawings, or you want it all in one? Okay. An airplane is flying at an airspeed of 500 miles an hour due north. I may have put something like this on the quiz because you can't hardly mess that up. What are the components of that vector? 0 left or right, and exactly 500 up. Yes? If you wanted to type 500 cosine of 90, 500 sine of 90, guess what you'd get? 0, 500. Okay? Just so you know. All right. If a 50-mile-an-hour wind is blowing at, okay, this means it's pushing it in this direction. It's not doing the opposite thing, okay? At a bearing of 270. So a bearing of, oh, you don't want me to draw on that one. You want me to draw this one. Bearing of 270, okay, is this line over here, right? And if it's blowing that plane at that bearing, it's actually blowing the plane that way, 50 miles an hour. So what are the components of that vector? Negative 50, 0, yes? If we were going to use cosine and sine, we'd have to have used either 180 or negative 180, okay? Now, determine the velocity and direction. Okay, so we're going to add them together. What are we going to get? Add those two vectors together and we get negative 50 and 500. And to find the velocity, that equals the magnitude. So we're going to do negative 50 or just leave off the negative. Otherwise, you got to have parentheses. I got 502.5. Anybody? Okay. Why is it not helping or hurting it more? Yeah, it's shoving it off course, right? By quite a bit. But it's not helping or hurting the plane's speed much because it's going at a right angle to it. Okay, how are we going to find the angle? that it actually ends up going. It's not 90. Okay, this is the resultant vector right up here. If we do inverse tangent, 500 over negative 50, what do we get? Negative 84.3. Okay. Is it really going down here? The calculator is confused. This vector is not in quadrant 4. What do we have to do? Add 180, okay. Unfortunately, that's not going to be the answer. So, the plane, just a minute. The plane is going here, okay? 95 degrees. 0.7. Did someone get that? Okay. That makes sense, yes? That it would shove the plane off course a little bit. Okay. You need to describe that to me. That's just how I asked it on the quiz. How far off course is it pushing the plane? 5.7 degrees. Okay. Is that an easy way to ask it? Okay. If you had to change it to a bearing, could you do that? This is 5.7, right? So all of this would be 350 something, yes? It's at a bearing of 352.3 or something, because it's 5.7 off course. All right. One more. What do you want to do? Pick one. How about this one? I don't know. I think how many parts does this have on yours? Just A and B? Number 6? I think I took that off. Okay. How would you do this? $2,000 cosine of 22,000 sine of 20. But you got to do something different down here. What's different down here? 1,500, but you got to do something else different. Got to use negative 20, otherwise you're going to end up adding things that's not pulling the same direction. Okay, what is the sum of the horizontal components? What is the sum of the vertical components? I asked this on the quiz because I want to know if you know the difference. What's horizontal? Left and right, which would be which ones? The x, right? So 2,000 cosine of 20, close parenthesis, plus 1,500 cosine of negative 20 is 3,289. I'm just going to round to a whole number. 2,000 sine of 20 plus 1,500 sine of negative 20 is 171. Okay. What is the resulting force on the tree stump? Yes, just find the magnitude. I got 3,293. Why did it turn out so big? Well, they're both pulling roughly the same direction, right? They were pulling absolutely on top of each other, it'd be 3,500. Okay? Is the stump going to end up going north or south of that dotted line? North of it a little bit, because the top one was pulling harder, right? The top tractor had more force.